Welcome. This is Further Solutions Academy. Further Solutions Academy. Encourage us more. Help us to share our video and also subscribe to our channel. This channel, any topic you have problem with, just get yourself there. The one that has parts, make sure you start from part 1. In this video, I'll be walking you through special function, part 1. Now, the outline of these special functions are, the first one is, I have gamma function, I have a factorial function, relationship between gamma and factorial, beta function, and relationship between gamma and beta function, and problems, general problems from integral. Now, if I'm talking about and this part 1, I'll be working on gamma and factorial function only. Gamma and factorial function only. Now, let me start the okay. I'm talking about special function for part 1. I want to work on I want to start working on gamma function. Now, if I'm talking about gamma function, it's very important that my gamma function is denoted by, that is how it's always denoted. Now, which is defined by gamma of x equals to what? Integral run from 0 to infinity, t raised to power x minus 1 and e raised to power minus t dt. Now, this is a very good example of what? Gamma function. For all my x must be greater than what? Is 0. My x must be greater than is 0. Now, if I have gamma of 1, it means I will be talking about what? Integral run from 0 to infinity. I have t of what? 1 minus 1, 1 minus 1, e raised to power minus t, the what? The t, which I will be having integral run from 0 to infinity. I have what? X raised to power 0 is 1, because this will give me is 1. Except is 0 itself, e raised to power minus t, exponential of that, which is, if I should integrate this, I'll be having integral of minus t e raised to power what? T dt. T dt, which is, it will run from what? Infinity to 0. Now, by so doing this, it will be equals to 1. When you find the limit of this particular function, it will surely be equals to 1. Now, that is the intro part of it. Now, if I have a function this way, if I have a function this way, I have this particular function. I have when x is an integer, n will have gamma of n equals to what? It run from 0 to infinity. I have t of n minus 1 and what? E minus t dt. That's all about that. Now, if I want to go from here, now what is very important here, I must to understand my integral by parts very well. What I will just do, let my u, my u equals to what? T raised to power n minus 1. And my dv, it will be equals to what? E bracket of dt. Now, if I have this, if I go by my integral by parts, which I'm to have, if I should do this, I will have Sorry, by now you should understand in our integral by parts. So with help of integral by parts, I will have of n, it will be equals to t of n minus 1 minus of t bracket, it run from what? 0 to infinity, and also I will move on minus integral run from 0 to infinity. I will be having minus t and okay, I'll be having to be continue I'll be having n I'll be having n minus 1, and also I'll be having the integral of n minus 1, which is okay, I'll be having n minus 1. Let me not put n minus 1, let me just put by integral first. I'll be having this, which is this n minus 1, close the bracket, and t raised to power n minus 2 and the t. Now the bracket close here. Now once I have this, it means my n, it will be equals to n minus 1, which is this n minus 1. Everything that is here, okay, let me not rush. Everything that is where become 0. It will become 0. I have 0. I have n plus n minus 1. I have n minus 1, and also integral run from 0 to infinity, and also e t and t raised to power n minus 2 dt. Now since I have that, it means I will now get my function from here. I will get my, this now will determine mine. It means mine, it will be equals to n minus 1. Everything that is here is the same thing as what? It's the same thing as lambda of, is the same thing as lambda of n minus what? Minus 1. Minus 1. N minus 1. Now that is what I'm having there. Since I have that, it means I will be having this. Now it means n of this equals to this. If I move on to the next one, similarly, now my lambda of n minus 1, it will just be equals to, n minus 2 and lambda of n minus what? 2. So and so on and so forth. If I have if I want to move on to the so that my n, so that n and lambda of n of this, it will be equals to n minus 1, n minus 2. It will run to okay, let me not run it. I need to run it up. Lambda of what? N minus what? 2. Which is, once I have this, now it's now continue by having, so that we can now continue like that. Now it means I can say that what? My lambda of n, it can be equals to n minus 1, n minus 2, and so on and so forth. N minus 2, it will run to infinity. It means I can say that what? My lambda of n can be equals to what? N minus 1 factorial. That is all about that. Now with the help of this, I can now do anything on what? On my gamma function. With the help of this, I can do anything on what? On gamma function. Okay, okay, let me give out some example on this gamma function. Example on gamma function. Now, I have this particular function to work on. Okay, I have this function. Evaluate 1. I have run from 0 to infinity, x of this, e of x dx. And another one, I have 2. I have it run from 0 to infinity. I run from 0 to infinity. I have 6 of x to the power east, e of x dx. Now, anytime I have integration like this, I have integral like this, the upper limit and the lower limit, and it appear like this. There's no way I can solve it. I will go by what? By special function, which is called gamma function. Now, how do I solve this solution? Solution to this problem. Now, the first one, I will move on by having, what is my integral? I have integral of, it run from 0 to infinity, x raised to the power 5, e of x dx. This can also be expressed as, I can express this as integral run from this to this, x of 6 minus 1, e exponential of x dx. What is very important there is this. Now, since I can express this, it means my gamma of 6, it will be equals to, this one is now gamma of 6. It will be equals to 6 minus 1 factorial. 6 minus 1 factorial. Another one, the second one, I have integral of what? Run from this to this. I have 6x8 e of x dx. Now, since I have this, I can write this as well. Since integral run from 0 to infinity, it must run from 0 to infinity, which is x raised to the power 8 e of x dx. Now, since I have this, I can say that what? 6 integral run from 0 to infinity, I have x raised to the power 9 minus 1 e of x dx. Now, since I have this, it means I'll be having this one will now be 6 gamma of 9, which is to be equals to 6 bracket of 9 minus 1 factorial, which is it will be equals to 6 minus 1 factorial to be equals to 6 times 8 factorial. That is my final answer. That is my final answer. Now, okay, with this, let me try to work on the one of fraction form. It's a bit complex. Now, let us try to work on the one of fraction form. Now, if the function comes in terms of fraction, for instance, we have if I have gamma of 1 over 2, it will surely give me integral run from 0 to infinity. I have t raised to the power 1 over 2 minus 1 and e of t dt. Very, very important. Once I have this, what I will just say, let everything that is there be equals to what? I equals to what? Run from this to this of t1 over 2 minus 1 e of s dt. Now, I can now go by my part. Let u squared equals to t. dt equals to what? 2u du. And also, when t equals to 0, my u also will be equals to curly. Now, when my t tends to infinity, my u also will be tends to what? Infinity. Now, it means this is equals to 0, 0. Now, when it's also be equals to 0. Now, I will now say that so I will now be equals to integral run from infinity to this, which is this to this. Now, I'll be having u raised to power what? Now, I'll be having my u and minus what? Okay, I'll be having my u raised to power. Okay, I'll be having u raised to power 1, and also I'll be having e raised to power minus u raised to power 2, and what? 2u du. Now, what I'm just doing there, I'm using my substitution skill. Now, with what I have here, I can say that what? This u and this u will become 1, which is raised to power 0, is raised to power 0. Now, I'll be having 2 integral run from this to this. Now, I'll be having e raised to power u squared and du. This and this will come out. Now, since I have this, I will have a function like this. Now, also, I can say that what? I can be equals to 2 integral run from 0 to infinity. I also has minus v squared and what? dv. Now, there are two things that are there. Now, once I have that, I can now have something like this. 2 times 2, it will be, so I will now be equals to, let me have I double, I squared. It will be equals to 4 of what? Integral of, it runs from 0 to infinity, it runs from 0 to infinity, which is, let me just, from u equals to 0 to infinity, and also integral of what? V equals to 0 to infinity. Now, which is double integral, I'll be having e raised to power u squared, e raised to power v squared, d, and now it will now be what? dv du, which is double integral. Now, since I have that, I can answer that 4 integral u to 0 infinity integral of u v to 0 to infinity. Now, e raised to power minus bracket of square minus what? V plus v squared, all in the name of dv du. Now, since I have that, I can now go by my what? Let my u equals to r cos theta and my v equals to r sine theta. Now, what am I working towards? I'm working on the what? Polar form. Now, I can now then I can say that what? U squared plus v squared can be equals to r, can be equals to r squared bracket of what? Cos square theta plus what? Sine square theta, which is also give me back 1. Now, which is give me back r squared. Now, since I have then and v all over u will give me what? R sine theta all over r cos theta, which it will give me tan theta. Now, since I have all this at hand, I can now move on and get what I need. Now, I can answer that what? I have to rub them again. Now, I can now move on by having this function. I can now move on by having, okay. Now, I can now say when my u equals to 0, v equals to 0, r also equals to 0, then when u tends to 0, to infinity, r tends to what? Infinity. Now, v u all over b, it will be equals to tan theta. Okay, now I can now move on when u equals to 0, my theta will be equals to which is 180. 180 is pi all over this. Now, with the help of Jacobian, u the v known as Jacobian also be equals to partial of all over what? Of r of u with respect of what? Theta, and also of v with respect of what? R, of v with respect of what? I'm just on my Jacobian now. Now, since I have this Jacobian at hand, I can now move on by having this will surely give me cos theta r sine theta and sine theta. If I differentiate this one, it will be giving r cos theta. Now, if I move this d r d theta. Now, if I move on this, I will have r cos square theta plus r sine square theta, which I will have theta, which it will surely give me when I do this, it will give me this r d and what? D theta. Now, it means my I of double, it will be equals to 4 of theta to 0 pi all over 2, and also r to 0 of infinity e of r squared and d r d theta. Now, since I have this, I can now move on by having, please just study the proving very well. Now, I can now move on by having, with the help of my integral, double integral. Now, I can now say that what? 2, I can split the stuff by 2. I have integral run from r equals to 0 to pi all over 2, and also open a brick bracket of minus integral run from what? 0 to term and e raised to power r squared and bracket of minus 2r close bracket d r and what? Now I will have my d r and my d theta outside. Now, since I have this, I can now move on by having, okay, these two are splitted, which is going to be 4 here. Now, since I have this, I can now say that what? 2 of my theta equals 0 and pi all over 2. Sorry, this is pi all over 2 minus e minus r squared 0 to infinity. Okay, I will be having my d theta. Now, since I have this, it will surely give me, this one will give me 1. 2 integral of theta equals to 0 pi all over 2, and this one will give me 1. Everything that is giving me 1, it will be what? D theta. Now, when I do upper limit and lower limit, then it will be surely give me 1. Now, which if I integrate this, it will surely give me 2 of theta run from what? Pi all over 2 to 0. Now, which it will give me 2 dots pi all over 2, which is equals to what? I will have pi. That is my answer. That is my answer. Now, before I close this part, it means my function of a if I'm looking for a lambda of this, I will need to have a pi when it's the lambda of function lambda of this form 1 all over 2 is not the same thing as lambda of what. Now I will work more on the next part because there's no time. Thanks for watching.